see the question, every single question from the sets which are given, it is like firstly prove, find out, check whether it is a concave or convex thing. Check for objective function, check for constraints. Once you do that, check it for Slater, like remove equal sign, and check it for inequality. Strict inequality.
Okay.
And then for what values of a greater than 0, you have to use Kuhn Tucker. Okay. Now,
Okay.
let's go one by one. First up, objective function. What do you think? Is it concave or convex?
Oh, this is what we had done. A log y plus 1 plus x. Ma'am, so it's upward sloping. Upward sloping logarithmic. Uh, is it convex, ma'am?
First of all, if you see it has logarithm, let's distribute this into two functions. So it is made up
Okay.
of one logarithmic function and another one linear function. Right?
Okay.
So, linear function and logarithmic function. Now, logarithmic function is how? You can see initially we think that, okay, it is, growing and then it slows down. So it is always concave. I can't write. Hmm. Am I audible?
Yes, ma'am, you're audible. But the OneNote is not responsive.
Yeah, just bear. So logarithmic function, you can do it in two manner. One is logarithm. You can apply that hill and valley concept and see if you draw the graph of log x plus 1 or y plus 1, you will find out that, okay, it is not, it is giving you a hill. First. Secondly, also you can apply second derivative test and see if it is coming as negative. You will say that, okay, it is what? Concave, right?
Yes.
So, are you trying to create a graph of it? Draw a graph, Desmos.
On Desmos, yes. Since I'm not able to see the screen.
Yes.
Hello.
Uh-huh. Let me stop sharing.
हाँ, मैंने मैम आई ट्राइड प्लॉटिंग बट देन यहाँ पे नहीं हो रहा है प्लॉट.
What did you write?
आई रोट द इक्वेशन. वो
Not
फंक्शन
whole
लिखा मैंने.
equation.
ऑब्जेक्टिव
Only,
फंक्शन.
no, not whole equation because it is a group. It has arbitrary constant also, no? A. Either you have to define it for A. Just write log x plus 1 or log y plus 1 in bracket and see what logarithmic function is like. Is it concave or convex?
ओके.
What do you think? If you take 2 points and apply that tangent concept or chord concept or maxima minima, hill valley, what do you think logarithmic is giving you? Or increasing,
मैम इट
decreasing?
इज गिविंग अ कॉनकेव फंक्शन मैम.
Correct. So, my logarithmic function has become concave. Next is linear. X is linear. So, linear function
Yes.
can be both.
Is both concave and convex, and we have an arbitrary constant 3a, which is
Huh.
again you're multiplying 3a. So if a is negative or positive, it'll determine the concavity or convexity, ma'am?
Yeah. You know what you can say? If it is the concave function and it is always, so condition for A is given to us. A is greater than 0.
A is greater than 0. Ma'am, so it's concave.
Yeah. So if you add, we talked about it, if you add anything to a concave function, it
Yeah,
gives the
it's an
concave
affine
function.
function, which it gives a it gives an upward elevated or expanded function.
It will not be in the form of increasing function always. It cannot be increasing always, right?
No, no, it is going to be concave.
Ha, it is concave. So it is asking is the
Ma'am, and
objective
this is
function.
affine, right?
Yeah, if you add a linear function to anything. Now, question was, is the objective function concave? Yes, it is concave. Next is, are the constraints convex?
Okay, that
So
we need to check.
constraints, we have y plus ax less than or equal to 1, y greater than or equal to 0, x greater than or equal to a. Now see, if you check this, whenever you have a convex function, upward
Hmm.
function, you have minima as a
Right.
vertex. So these are convex because y is greater than or equal to 0, x is greater than or equal to a, and a is greater than
A is greater
0.
than 0.
So it is an increasing function, convex.
Yeah, it's linear and increasing. Since it's increasing and linear, it's convex.
Yeah. Now, what about y plus ax less than or equal to 1?
Y plus ax, y is convex. A and x is both convex since a is greater than 0 and x is greater than or equal to a. So it is convex, but less than or equal to 1.
You know what? You need to see it this way. Whenever you solve any inequality, it is if it is a linear inequality.
Hmm.
Uh, Tell me if you are given this, what will be the value of x?
Ma'am, so it could either be x is less than 3, less than 2,
Okay.
or it could either be so when is x goes this x is more than minus 2.
So what you have is you consider it as plus minus 3. I mean, if it is
Yes.
less, and then for you can put less than 3 and less than minus 3. So you'll get minus 4 and 2. So x lies between minus 4 and 2, right?
Ma'am, 1 second.
Hmm.
Less than minus, no, less than 2 and yeah, okay, yes.
Now tell
Hmm.
me one thing. If you have something uh, which which is a mix-up of two feasible solutions, so that will be enclosed only. So it will form a lower bound set. So convex, this is a reasoning which you can give when it is what? A linear inequality. Do you want me to tell you again? Process.
Yes, ma'am.
Okay. See, it is asking me whether the constraints are convex or not. Now I need to check convex to prove in fact, it is not asking me to prove, it is just to check. So I can check if the function is increasing. I can check if it has a minima at vertex. I can check if it is a lower bound.
Hmm.
So that valley thing.
Yeah.
So lower bound means you have a function, for example, and lower bound, it will be defined
Yeah,
somewhere here.
the lower count. Yeah.
So
Lower contour. Yes.
for that, you will be having the maxima. Yes or no?
Hmm.
So in all these cases, you can have convex. So these two are sorted. Now I have to check y plus ax less than or equal to 1. Either you can see whenever there will be KKT, you see, you will
What is KKT?
get,
Kuhn Tucker theory.
yeah, you will always get your constraint as convex and your optimizing function as concave. This is the condition to apply KKT. But we
Okay,
have to
writing it
check
down.
here.
1 second, ma'am.
Huh.
Ma'am, will you
I,
be teaching KKT separately?
I'll tell you the conditions when I'll tell you the difference between KKT and Lagrangian. Okay?
Okay.
Hmm.
Ma'am, so over here in KKT,
Hmm.
my objective function
Is
is
concave.
concave.
And constraints have to be convex.
Why, ma'am?
I'll tell you. First of all, let's not go by the convention that it is it. Let's check whether these are convex or not. We have checked these two are convex. Now need to check this one, right?
Yeah.
Y plus ax is less than or equal to 1. You consider anything in place of x and y.
Hmm.
Okay. Once you take x1, y1 and x2, y2, you will be doing it
Hmm.
on the graph in a while. X1, y1 and x2, y2 you take so that they can satisfy this condition and these two also, which you have already proved. And if you
Okay.
have this t 0 to 1, have that
Hmm.
linear combination in the form of function. So it will be having x component and y component. X means
Right.
tx1 plus 1 minus
Plus
tx2,
1 minus tx2. Yes, ma'am, this I
ty1.
know. Or ty1 plus 1 minus ty2.
Huh. So if it this is lying between these two, you will call it convex, right?
Yep.
Now consider those 2 points.
Ma'am, how, ma'am? How if it lies between that two is would be convex?
Because it is lower contour. So convex has minima. Did
Right.
you
Convex has maximum, ma'am.
did you no? Let's say I have this
Oh,
increasing
convex has
function.
minima. Convex has minima. Yes,
Yeah.
convex has minima.
Huh.
Yes.
So it has to lie between, I mean, it has to be lesser than the maximum of these two. Then only it will
Right. That's my
form,
corresponding theorem.
yeah,
That will give me quasi-convex.
quasi-convex. But the convex thing also has to be a minima, and minima can be pointed out in the form of either lower contour, if we are talking about on the plane. You consider any 2 points, right? This particular point
Right.
has to be lesser than the
Less than
that
the
maximum
max of.
max of
Got
these
it.
two, right?
Max of one coordinate, one x comma y.
Lesser than maximum of one of these two. Just say through which we have made the line which is connecting these 2 points, right?
Okay. Ma'am, so over here x comma y, x1, y1 and y, x2, y2 are ordered pairs. So what we are trying to do here is, ma'am, we
Hmm.
are given a question
Huh.
where we have an objective function to maximize. है ना? And this
Yes.
objective function is a part of an open or convex set,
Hmm.
and it has some constraints. It is subject to such that y plus ax is less than or equal to 1. That is one constraint function that's been given to us. And we have two more linear functions that are also constraints that are binding this time. And they are telling that these constraints are y greater than or equal to 0 and x greater than or equal to a.
Yes.
Now, we have found that the objective function is concave. How
Hmm.
have we found out that? We dissected the objective function.
Yes.
We know that log of y plus 1 is logarithmic function is a concave function. We
Hmm.
know that. X
Hmm.
is an affine. When we add x, it is again an affine function. So
Hmm.
it is a linear function. Function can be a concave or convex, and we know that since x is greater than 0,
Hmm.
greater than equal to a, and since a is greater than 0, and if since all the constraints are binding, we know that the objective function is concave.
Concave. Yeah.
Then we prove that y is greater than or equal to 0 and x is greater than or equal to a are both convex in nature
Yes.
because it is an increasing function.
Yes.
It is following the norm of convexity. We haven't proved that this has a relative minima or a minima.
Yeah.
We
Because
have just gone at
they don't have implicit functions like function within function. Only one variable is
got
there,
it.
so we
Our
can.
objective function had an implicit function,
Huh.
and
Objective
our
function
first
has that.
constraint as
Yes. One of the
is
constraints
an
also
implicit
have.
function.
Huh.
Got it, ma'am. And our constraint ka now we are proving that the first constraint is also convex.
Yes. So how are we proving it? You can use
How are
any
we
of the
proving it?
we can use any
We
of the
have
methods. Huh.
hmm,
Either you can prove that it is an increasing function or it has minima at the vertex or lower bound condition. All these things form convexity. Now
hmm.
you have y plus ax less than or equal to 1. You can have anything. See, if I assume my x and y something, for example, y is what is the condition for y? Y is greater than or equal to 0. So
Yeah.
let's have point 1 and x is greater than a, which is greater than 0. So I can have x as a plus 1. Yeah,
Hmm.
a is greater than 0, a plus 1. If I substitute everything here, y as point 1, a, x, a plus 1, I can get the value
Ma'am,
of
on
a. Huh,
one doubt, ma'am.
huh,
अभी हम लोग can you solve the problem there with using the uh, using the so we started proving that it is through linear combination. We started proving that the first constraint is convex in nature.
convex. Huh,
We took two points on the graph,
huh.
right? Could you give an example and solve them so that
Yeah,
it's
sure,
clearer?
sure. Y plus ax less than or equal to 1. Let's assume if we can have x1, y1, the condition of x1, y1 should be should be in manner that all those other constraints which we have already proved that,
Should be binding.
yeah. So x1, y1. So I'm considering that my x1 is, let's say, what? Point
Point
1,
point four point
point
okay.
4. Y1
Hmm.
is
y1 is 0.2.
There is no relation between x and y, right? It's just if y is greater than or
No,
equal to 0 and a is greater than 0, so x has to be greater than 0, right?
yeah,
If x has to be greater than 0, least value of y can be 0,
0.
but
Yes,
x will be greater than 0. This is something which we can have. Okay. X1, Y1 we have talked about. So A will become what? Y is
ma'am.
point.
So why do we need a here, ma'am?
We have to calculate everything so as to see whether it is an increasing or decreasing function or whether it is giving me, I mean, convexity has to be proved. If it is this
मैम
way,
अगर हम लोग अपने लीनियर कॉम्बिनेशन से सॉल्व कर रहे हैं ना मैम.
huh? But for that also, you need that particular perfect value of the function, right? The whole function
Okay,
is in the form of y plus ax less than or equal to 1. We have three unknowns.
okay.
Yeah.
Hmm.
So what can we have? X1, Y1, 0.4, 0.2. Tell me what is the value of a from here.
Ma'am, so it's gonna be 0.2 plus 0.4, 0.4 a. So 0.4, 0.2 करके 0.8 x 0.8 divided by 0.2. Oh, it's gonna be 4, ma'am. So ये ज़्यादा हो गया.
Less than a. But condition for a is greater than 0. It can be 4, no?
Yeah, मगर the function is should be less than or equal to. Oh yeah, yeah, yes, ma'am, you're right. Yes, it can.
Zero point 0.2
Yes, yes.
plus a, 0.4 less than or equal to 1. A has become what? So you have considered x1, y1 and a has come out as 1 minus 0.2, 0.8, y 0.4, 0.2, no?
Yes, point. A is point 4, ma'am.
How?
4
0.1
आया.
minus 0.2 divided by 0.4. So 0.8, 0.4.
मैम 0.8 divided by point. अच्छा 0.4 क्या? So 2 आया.
Okay. So we have got variables a, x, y as 2, x1, y1, a1 also. 2.4, 0.2. Okay. What about a2, x2, y2? Considered
Uh,
anything else?
point 0.1 point. मैम 0.1 0.3 where my y is 0.1 and x is 0.3.
Hmm.
उल्टा मैम.
Tell me
I
what is
think that
a
will
now.
be easier.
Oh,
Ma'am,
you
can you
want to
switch it
take?
because it's gonna be easier.
Acha.
अच्छा, it's gonna be the same actually, but not same. It's gonna be easy regardless. मैम इसका हो जाएगा 0.1 उधर गया तो 3 मैम.
Now, t. What do you want to suppose t?
मैम 1.
0 to 1. Okay, 1 can have.
इसमें तो वाले तो वही हो जाएगा.
So, if you now substitute the values, this tx1, the function will become how? What? Tx1, that is 1x1
Hmm.
plus 1
So
minus
1
t.
into x1.
This is gone, 1 minus t.
0.4 plus 1 minus t is 0. 0.4
It is gone.
comma. Uh, so this is going to be 0.2 by 1. So 0.2.
0.2. Okay.
0.4
Tell
0.2.
me, and it is lying between. This is my function. My x1, y1 and x2, y2s are these. So what do you think?
Hmm.
What are we getting in the form of function? Is this value y plus ax when if I'm putting
Hmm.
y1 plus ax1, is it less than the function or greater? Function value is 0.4, 0.2. So x part is zero point 0.4. What I'm putting here, 0.2
Ma'am, it is
plus,
less than or equal to 0.4.2.
right?
Right.
So can you say that this is the condition for convex? Because whenever,
Convex. Yes.
is this fine? You could have solved it in easier manner also because you know this is of 40 marks, but this first part is only of 6 marker and it has multiple things. So you can see that other constraint convex, it is hardly of 1 or 2 marks, right? You have to
Hmm.
invest here. So for that, try that you don't invest thinking about the coordinates, and you can work around the statements. So what you could do, y plus ax less than or equal to 1, you could have said that this
Hmm.
is an affine function
Yeah.
which is lesser than a limit, which is the condition of sublevel sets of convex, right? This is the condition. That's what we have proved. You can say that this is the linear combination and it is lesser than 1, which can be expressed in the form of, if you take a, x, y, and your t belongs to 0 to 1, just by statements that if we pick any two solution, x1, y1, x2, y2, which satisfies y
ಏನಿಲ್ಲ
plus,
ಏನಾರು ಬೇಕಾ ಊಟ
हाँ बोलो,
ಚೆನ್ನಾಗಿ ಇಸ್ಕೊಂಡ ಸುಮ್ಮನೆ ಅದೀಗ ನನ್ನ ಡ್ರೈನಿಗೆ ಹಾಕ್ಬೇಕು
sorry,
Right, ma'am. No, no, my mom was here to give me
अच्छा
food.
अच्छा,
Sorry, ma'am.
okay,
ಸಾರಿ
okay, no problem, no problem. So what you could have done, instead of taking examples and investing your time in it, you could have simply said that this is an affine function
Hmm.
which is having a limit lesser than or equal to 1. Now, if you consider
Okay.
any x1, y1, x2, y2, two coordinates between, if you pick up any these two coordinates such that the limit is satisfied, which limit? Y plus
With
ax less
less
than
than
or
or
equal to
equal to
1.
1.
Then there exists t, another parameter, for which this whole thing is less than or equal to tx1 plus 1 minus, I have written already, right? 1 minus
Yeah.
tx2, this one. So hence it is convex. Are you getting my point? Now you might be wondering that, ma'am, for this we know if it is KKT, then we have to prove convex. But what if we have to check and that thing doesn't come out
Turn out to be
as
convex.
convex? Then what will happen? Then you have to certainly invest time in thinking about what needs to be x1 and x2 and y1, y2. Okay?
Got it, ma'am. ये मेरे को लास्ट कॉन्सेप्ट अफाइन का आई एम स्टिल नॉट वेरी श्योर
Acha.
मैम
Okay, okay, hold on.
conceptually I'm not able to understand.
Okay, okay, let's say you have, what is the condition? Y has to be greater than 0,
But
A is
with
greater
this
than
age
0, X is less than or equal to A. X is greater than or equal to A. Now see, instead of this, if I have 2 plus 3x, can I have it? Y is greater than 0, A is greater than 0. Uh, but for that, it has to be less than 1. You consider any such, if you have 3x plus 2, for example, What do you think? Is it convex or concave?
Ma'am, it's convex.
2x plus y. Now
Convex, ma'am.
think this is a fine function and we are adding, and we have already taken all the positive values only, so it is going to give me convex, right?
Yeah.
Now, even if they are saying less than or equal to 1, that doesn't mean that it will give me negative values. If I am choosing all of them positive, that means it is going to lie between 0 and 1. This function
Yeah.
will always give me, keeping these constraints
Since
in mind,
everything is positive, yes.
everything will be in this manner, that's 0 and 1. 1, and those are also what closed intervals. So what do you think?
Yeah.
It is still positive. It is convex. Are you getting my point?
Oh, yes, समझा ma'am.
So you can have theorems to prove it if you have strong reasoning in place, or you keep
No,
on,
but then this is very easy. The last one, it just took 2 minutes.
yeah, you can put values and check for every constraint, and this is how you'll get. Now, this part is done. We have to prove for what values of A, greater than 0 is Slater condition satisfied. Now, for Slater condition, we know Slater condition is for strict inequality.
Yeah.
So I need to check Slater condition for all of them. That is x greater than a, y greater than 0, and y plus ax less than 1, right?
Hmm.
Now, tell me, what can I assume? See, if I have to prove Slater, if I have to remove the equal sign, the only option to prove is consider hypothetical values, like assume some of the values for one or two of these inequalities to be true, and check this for the third one, whether it is following or not, right?
Ma'am, but over here also it is convexity only, no, it is following. Since x is greater than a and a is greater than 0, we know that, and y is greater than 0, so the all of these are convex.
Correct,
Since
but
again over here the affine function is also convex.
now we are not asked whether it is convex or concave. We are asked whether Slater condition is satisfied or not. That is, if without including a, without including 0, without including 1, are these being followed or not? Okay.
Ma'am, what without including a, 0 and 1, what is being followed? What
The
and all are being
conditions,
followed is what?
the conditions are applying here or not. For example, see, if you can see x is greater than a, can I assume that x is a plus 1? Because then only x is a plus something. It can be 1, 0.1, 0.2, anything, right?
Yeah, x is greater.
Now,
Yes, ma'am.
I have assumed y is greater than 0, so let's assume y 0.5. Anything you can assume. Just
Okay.
see the logic. Once you have already considered that first two are true, I mean, you have considered any value from the limit, then check it for the third one. Substitute all those values and see whether it is coming out as less than 1 or equal to 1. Okay?
Okay.
So y plus ax. Y is 0.5. X is a plus 1.
A plus 1.
So if you want, see, it can be anything. It can be greater than 1
मैम
also.
मुझे अभी भी
हाँ,
स्लेटर कंडीशन ढंग से समझ नहीं आ रहा मैम।
हाँ, अभी
स्लेटर
अभी आएगा।
कंडीशन वी आर चेकिंग। हाँ।
हाँ, अभी I'll summarize this for you. Just see what I'm trying to say, and then I'll summarize, and you will be able to collect all of it together to define in your
ओके।
own way what is Slater. Okay.
ओके
So
मैम।
y plus ax has become this 0.5 a plus 1. I need to prove, I need to find such a value of a. Once you find a, you will get x also. You will get this whole function also. You need to find such a value
या
of a for which the Slater, that means strict inequality, not equal to 1, but less than 1
लेस
will,
देन 1 इज फॉलोड।
yeah, will be followed or will be held. So if I'm substituting this, I mean, if I'm considering and I have to prove that this is lesser than 1, that is a plus 1 less than 0.5, right?
Yeah,
1
so a
minus
square
0.5.
plus a is less than 0.5.
Huh. So either you can use quadratic equation to solve it, or tell me this. When can you get this square function like a into a plus 1 less than 0.5? Not for bigger values of a. It
No,
will never be followed if I substitute a as 2. So 2 into 2
no,
plus 1, 3. It will never be being followed. So
no.
it can only be possible, let's say, if I suppose a is 0.1, because a is greater
If
than
points
0.
are between 0 and 1 is when it can be followed.
Correct. So 0.1, 0.1 plus 1, 1.1. So which is 1.1, 1, 2, 0.11, which is less than 1, right?
Yeah.
So question has asked me, for what values of a? Which value of a should I consider by which I can say that Slater condition satisfied? Slater condition
समझ
means
में आया मैम।
the conditions
Strict
without
inequality
equality.
condition for the
Correct.
constraint is satisfied. Ma'am, so over here,
Hmm.
Slater condition satisfaction के लिए मुझे arbitrary constant का ही बोलेंगे क्या हमेशा?
Yes, because x and y,
Why,
uh,
ma'am?
the condition for x and y has already been given, and a depends. See, x is greater than or equal to a. It is all again. Okay. So you were asking that why it is so that always an arbitrary constant for Slater, not
Yeah,
x and y, right?
yeah.
Think that the constraints x and y are unknown. They only depend on what? Some numbers like less than or equal to 1, greater than 0, or any arbitrary constant a. Function
In this
has,
case only, no, ma'am?
yeah, basically optimization function, optimizing function has some variables. Those variables will depend on the constraints. So these constraints are defined for them. And these variables are dependent on those values. So those arbitrary constants will be asked to prove anything, when whatever it, be it convex or concave function or Slater condition or KKT, that will be for the values on which x and y depend, right? Does this make
समझ
sense?
गया मैम। Yes, ma'am, it does.
Okay. So what is next? Slater condition?
KKT,
Huh. KKT, right. Now see,
finally.
we have to understand the difference between Kuhn Tucker and Lagrange. Both
Okay,
are
ma'am.
similar. I mean, now we are trying to optimize the value, want to find out whether it is maximum or minimum. Most of the cases,
Okay.
like you can say all of the cases, Lagrange When Lagrange will be given, equality constraint has to be there.
1 second, I'm writing it down.
Yeah. Constraint should have equality.
Okay.
Whereas Kuhn Tucker will always have inequalities.
Ma'am, strict inequality or inequality?
Inequalities. It can be strict, it can be slack. Then, you know, Lagrange multipliers or Lagrange multipliers in Kuhn Tucker, multipliers have to be found out. But those multipliers
Hmm.
do not have any constraint in Lagrange. They can be negative, they can be positive, they can even be zero. But in Kuhn Tucker, they have to be non-zero. So non-negative is the constraint. There's restriction that multipliers have to be non-negative if you are using KKT.
Writing it down, ma'am.
Yeah. Then whenever we say Kuhn Tucker, there are some terminologies which we use. One is primal feasibility.
Zero. Negative. Okay, ma'am, could you repeat that?
So whenever now this is the difference. We are coming to the elaboration of KKT. It has primal feasibility.
Okay.
Which is, basic terminology. If constraints are hold, that means primal feasibility is there. Feasibility of the
Constraints
constraints.
hold.
Then they have dual feasibility. That means the multipliers are either zero or positive. Only two things are possible. They are non-negative. This thing, multipliers are non-negative. This thing is called as dual feasibility, okay? So two values are
Okay.
possible, zero or positive.
Ma'am, so your KKT can have, so there's one primal feasibility, then you move on to a dual feasibility when the constraints hold as well as your multipliers are non-negative.
Yes. That
Okay.
means it is related with another thing which is called as complementary slackness.
1 second, ma'am. Oh. Constraints, multipliers, non-negative. इसके बाद complementary slackness.
So what is that? Slackness has slack word. Slack means equal to.
Slack is equal, yeah, slack inequality. It's not unlike Slater.
Yes.
It has equality.
No, strict is Slater.
Strict is Slater, and slack is non-strict. So it has,
Equal to sign
it has
also, right?
equalities. Yeah.
Equal sign is also there. So just before this, you asked me, how come? I mean, this was a question mark like thing that primal feasibility is there, like constraints are hold, and still multipliers have to be zero or positive. So there can be two things. If you are including slackness is there, yeah, that means you have less than or equal to or greater than or equal to inclusive nature of inequality is there.
But ma'am, 1 second.
Huh.
Yeah, so in primal feasibility, we are telling that the constraints hold. And over here, we know that.
Yes.
Oh, समझ गया हूँ.
So,
But over here, the constraint No. I got confused between the constraint and the Lagrange multiplier itself.
I got you. Let me rewrite the function for you. The final function is like gxy, like f in terms of xy, and then you subtract, you take away what?
Minus
Lambda
Lagrange.
k minus gxy, right?
K minus G. So yes, these are Lagrange.
Ha. This value, you will do the same process in KKT also, but
Okay.
this value along with the multipliers, there can be two things. That is complementary. Complementary means or either your constraints are active, that means they hold the equality. And when it is so, your multiplier will be positive. Or constraints are inactive. I'll explain you with an example, and multiplier will be 0.
1 second, ma'am, I'll note this down. इसमें for two things. One, constraints are active.
And multiplier is positive.
Active. And multipliers are positive. Or constraints are inactive. And multipliers are multiplier is 0 or negative, mama.
0 or positive. This is not this is not anything. Because we have only the case of 0 and positive feasibility. So when multiplier will be positive, when constraints are active. When it is 0,
मैम सो
when
हम लोग का प्राइमरी feasibility ये था कि if the constraints hold.
Yes.
And the constraints, and in this case, what do we mean by constraints hold? The constraints are unequal, can be unequal, and if the constraints hold, that is when we tell that we are function is primarily feasible, or it has
Yes.
primary feasibility.
Yes,
Primal
and
feasibility.
multipliers are positive in that case.
And ma'am, if multipliers are positive, then we have dual feasibility, no?
Dual feasibility is for both 0 or positive.
Okay.
But these are complementary with each other. Constraints hold means multipliers positive, and complementary of this is when constraints are not held, that means multipliers are 0.
ठीक है, but still is dual feasibility.
हाँ, 12 तो इसीलिए because we are having constraints as we are having multipliers as two forms.
Yeah.
As in two
Ma'am, but
forms.
again, on the other hand, if multipliers, if it's 0 or negative, it is not necessary that the constraints hold, right?
Yes. So first thing is same. What you will do, you will check the stationarity. That means stationary points. Partial derivative. You have to put them 0. You know what does it mean? Zero means gradient change is zero. That is where the surface is flat.
Yes, it's neither an increasing
Increase.
or a decreasing function. It's a critical point.
Correct, correct. So you always substitute. For example, so this is the things. First of all, these are the things. Firstly, you will be having the function. You will check the optimization, whether it is concave or convex, the function. Then you will check the
Okay.
Slater condition. I mean, firstly, the condition, whether
Hmm.
these are convex or concave. Then you will check Slater condition. You will be asked to check Slater condition for the strict inequality and find the value of arbitrary constant.
Okay.
Once you do that, then you substitute the function. I mean, find out its partial derivative, substitute it to zero. Okay. Once you do that, you will
Hmm.
get the function, and I mean, you will get the values of what? Lambdas and,
Yeah. And
the
XY and all the
variables.
other variables, implicit function variables.
But remember the condition for the multipliers you have to substitute. You have to find out the values from this also. More equations you have
Yeah.
to form that they will be greater than or equal to zero.
Yes.
Okay. So you will say that this is dual feasibility. This was stationarity. Then you will apply primal feasibility, like checking the
The
constraint for
constraints
the
hold.
function for each
This we
inequality.
used to do in Lagrange also. No? We should substitute all of the values of the
Correct.
lambda or
Correct.
XYZ in the
Then
way.
only we'll be able to find out whether it is maxima or minima, local or global, right?
Yes.
And then once you are done, then you have to use the complementary slackness, means just substitute whatever, this function, where is this one? Just substitute this part as zero and find out the values of lambda 1, lambda
Which
2.
part, ma'am? Ma'am, could you show?
Yeah.
Again?
This function, it has the expression of the part in which Lagrange multiplier and the k minus gxy is there. You have to substitute that
Yeah.
as zero. Okay.
Hmm.
Complementary to slack. Substitute it to zero and find out the value of lambda. Are you getting my point?
Okay.
Once you do
Yes,
that,
ma'am. I
you
think it'll be better if I solve a sum with an example.
then you'll find out the feasible region. Let's
What's a
do this
feasible
question.
region, ma'am?
Feasible region, on the graph, wherein, for example, if I have drawn this question, has asked me x greater than 3. So I'll have 1, 2, 3. This is the line. Greater than 3 means this. Then I have y
Yeah.
less than 0. So y less than 0 means this part. So my
Hmm.
solution is where both of them lie. That means this is my feasible solution.
Oh,
Okay.
समझा.
Boundary and the region within wherein the constraints hold. Now the question was this. So for what values of A greater than 0 can you solve the optimization problem using Kuhn Tucker? So firstly, you need to find out what is the value of A for which KKT can be hold. Okay.
Okay.
Then based on this question also only the extension. Suppose the restrictions on A found in part A hold. So whatever the value of A you found from A part, those are there,
Okay.
then you have to write down all those conditions for Kuhn Tucker which must be satisfied to use to maximize the Lagrangian. And then third part is solve for it. Let's start. So first up, what we are supposed to do, my function is, that is the most important thing, 3a log y plus 1 plus x.
मैम
This is my
लॉगरिथमिक के अलावा ओके ओके नो प्रॉब्लम
this is my function, right?
या
Now, if this is the function, also the constraint, what? Again, I have to write, hold on. Let me copy paste it
सो
there.
y प्लस ax लेस देन और इक्वल टू
Huh, you can tell me. Yeah. So constraints are
y is greater than or equal to 0 or y plus ax is
less than
and
1,
x is greater than a less than or equal to 1 ma'am. And x is greater than e, yes.
equal to, and e is greater than 0, right?
Yes. Yes.
So first of all, if I have to, we have three constraints here. 1, 2, 3. This was for Slater. It was given. Then
Okay.
if three conditions are there, that means three multipliers have to be there. We have two variables and three
Oh my God.
multipliers. So that means these 5 parameters. So I'll write the function. First of all, it is same as we used to do in Lagrange. Log y plus 1.
Ma'am, I'll note it down. Just 1 second, ma'am, simultaneously.
Huh, huh. Okay, let me ask you to do it. So just write your function first.
Yeah. Y plus 1 plus x.
Yeah, done till here.
L x y lambda 1 lambda 3 is equal to 3a log y plus 1 plus x minus three constraints
So what we do?
minus
Plus,
lambda.
we can have plus. Later on, we'll find out 1 minus. You will do 1 minus y
Okay.
plus ax, right?
Yes, ma'am. Yeah. So 1 minus y minus ax.
Then lambda 2.
Oh.
Y. Then lambda 3. X minus a, right?
Yes, ma'am. Lambda 2y plus lambda 3x minus a.
Once you get this,
Ma'am, a minus x.
a minus x. Once you get this,
I mean, that wouldn't make much of a difference.
huh, then we should do 0 minus y, right?
Yeah.
1 minus, hold on.
Y minus x is fine, ma'am.
No. One thing we need to check. If we have, is a,
Constant remains there, ma'am.
so see, if it is less than or equal to 1, I'll say 1 minus y minus ax, right? Because 1 is greater. You have to take,
Yeah, but then, ma'am, the constant remains there, no?
yeah, that's how we apply minus lambda 1 and lambda 1 accordingly. So you need
Oh,
to do
okay.
it this way. I'll rewrite. I don't know why eraser is not working. Now it should work. Let me cut it down. Okay. So plus lambda 2 y plus, because these are greater than lambda 3 x minus a. Okay. Just remember one thing, keep it uniform so that it will not impact your
Ma'am,
thing.
lambda 2.
It is y greater than 0, no?
Yeah.
So what will happen? You will take y minus 0. Here you greater than 0. Then here you will have x minus a greater than 0.
Oh, ma'am, I didn't know this. I didn't know this, ma'am.
Or if I skip this. So here you have to consider the positive values only, right? Values for lambdas have to be positive, right? That's why you are taking it from positive minus, from greater number minus smaller number. Okay.
Okay.
Is this fine?
Okay, samjha.
You will not do the same thing in Lagrange. Here you have to do because
हाँ
there
मैम लेग्रांजे में तो इक्वालिटी
Lagrange
this
में we
तो
used to do k minus gxy
k
only
minus gxy,
because
yeah.
it doesn't matter whether we are getting lambda negative, positive or 0. But here you have to do maximum minus function, be it
To get
constant
lambda
or
value as
function.
positive.
Yes, yes. Okay.
So over here, we know that since 1 is less than the function over there,
No, one is
1 is greater than the function. So
huh,
it's going to be 1 minus x minus ax. Over here,
1
we know
minus
it's going to be y minus 0.
yes,
And the next is going to be x minus a.
yes.
Lovely, got it.
Now, what is first thing, the stationarity?
The first difference, lx.
So tell me, what is partial derivative with respect to x?
Ma'am, so
Something?
it is going to be, yeah, it's going to be 1 plus
1 plus
uh, lambda ka, it's going to be 1 minus
here minus. Okay.
lambda a,
Okay. Then
uh, plus lambda,
plus lambda 3.
lambda 1, lambda 3
And you have to substitute it to 0.
equals to
Uh,
0.
then with respect to y,
Ma'am, it's going to be 3a
if you do it with
derivative of log is
1 by x, log x is 1 by
1 by
x.
x, by x.
So
So it's going to be 1 by y.
1 by 1 plus y, right? Chain rule.
Okay, yes.
Then
3a divided by 1 y plus 1. Plus,
hmm,
no, actually, minus lambda 1,
minus lambda 1,
plus lambda 2.
lambda 2.
That's it.
Okay,
Equal to 0.
right. Then Of course, I can't solve it fully because I have 1, 2, 3, 4, and 5. 5
मैम
unknown
अभी हम लोग को
variables,
लैम्डा का वैल्यूज भी निकालना है ना?
everything. With 5 unknown values and 2 equations, it is next to impossible. So, other constraints, I mean, other properties will also need to be applied. So, lambda, what is dual feasibility?
Ma'am, dual feasibility is when the constraints are holding and the multipliers are non-negative.
Yes, dual feasibilities, multipliers are non-negative. Why is
हाँ.
lagging? Am I audible?
Yes, ma'am, you are audible.
And why is lagging? Then primal.
It is lagging.
Oh, just bear with me. Primal feasibility, is it better?
Yes, ma'am, it is better now.
Primal feasibility means those constraints which are given should be applied. Y plus kx less than 1. So you have to find out all those values of unknown, keeping these constraints in mind. Okay?
Okay.
And then you have complementary slackness. So what does it mean when I was telling you slackness?
Ma'am, there are two kinds of complementary slackness. One is when the constraints are active, one is when they're inactive.
So when you put the multiplier as 0,
I put the multiplier as 0 when the constraints are inactive.
inactive, that means you are not considering the function, this value. Forget about this and substitute this as 0. This as 0. This as 0. Okay, Purshit?
Yes, ma'am. Ma'am, voice is lagging a little.
Okay, let me come up again. So what does it mean? You substitute. Slackness means multiplier will be 0 if constraints are inactive. So just forget about the constraint x and y values and a value. Rest, whatever is there, the multiplier and the expression, put them 0. Lambda 1 minus, what was it? 1 minus y minus ax, put it as 0. Lambda 2y,
Why, ma'am?
telling you. So what we talk about, KKT holds complementary slackness, means when slackness means both, again it is lagging. Slackness means
Yeah.
both equal and relation, positive, greater than or less than, right?
Yes.
When it is complementary, means one of the things have to be taken care of. Other than that, you will skip other things. So what you are doing, you are substituting your multipliers as 0, but for that, what it has to be? The condition is constraint should be inactive. How can you make them inactive? You cannot take the converse. But for the time being, you can leave them in order to substitute lambda 1, lambda 2, and lambda 3 as 0. Because then only multipliers
Got it.
can be 0. The
And that's when
function
my
will be
constraints are inactive.
yeah.
Ma'am, but then why do we have to make them inactive?
Yeah, inactive means, see, we want to find out the boundary, the solution within that. So I'll tell you, we later on, once we find everything out, A, Y, X, you draft it, you draw it on Desmos, and you will see that
Okay.
this, considering these inequalities, with these inequalities, there are so many solutions. shaded part. How can I find the solution? I need to check it for slackness equal to, greater than, less than, everything. Less than is not the condition for KKT. And once I'm doing it,
Okay.
then only I'll be able to get the feasible solution within all those constraints. And also, without this particular condition, five variables, I mean, five unknown things, without five equation, you cannot find out, right?
Right. It's not very easy. It's not possible.
Then, so once we do that, now we need to find out the values. So
Okay.
in the previous question, we are only asked that what is the condition? Just explain how KKT will be applied. They have not asked us to solve it in B or C part. Let me show you.
Yeah. How it is going to be applied. The third question as solving.
Yeah. So first is for what values of A greater than 0 can you use Kuhn Tucker? We have only talked about what will be the conditions for Kuhn Tucker. Now let's find out what will be the value of A for Kuhn Tucker now.
बाप रे.
40 marks. So for value of A, if I have to find out, I need to check the feasible region wherein A lies. So what is given to me? Again, I'm not writing again. These conditions are given.
हाँ.
So then what can be the smallest possible value of X? X is A.
X is A plus some value.
X is A plus some value. But what is the smallest
Yeah.
possible value?
It's the 0 plus something. Uh, uh, is A, ma'am. A. Possible value is A.
Correct. It's like X is A. We can
Yeah.
extend the class, right?
Hello. Yes, ma'am. But it's just that it's थोड़ा ज़्यादा हो रहा है information. We can do.
Okay. Smallest possible value of X is A. Now, what it will be, because I need to focus on A only. So I'm finding out firstly what is X, what is Y, so that A can be easily uh, found out. So using Y greater than 0, see, Y is greater than equal to 0. X I have found out, like considered. So tell me, if I substitute Y plus AX is less than or equal to 1 is there, right? If I take Y as 0 from here, AX is less than or equal to 1? Yes,
Y
Purushan?
is greater than or equal to 0. Yes,
Just
ma'am.
like, just like I found smallest possible value of X,
Yes, ma'am. The
smallest
smallest
value
possible value of Y is 0.
0. So if I substitute my A, I mean here X is,
क्यों लेते हैं मैम smallest possible value?
because I have to find out A. And I don't know the infinite, I mean, it is an infinite number. I don't know the upper limit. Only using lower limit, I can find out what is A actually, right? Within which range it is lying.
Yeah.
I need to solve it for A. And in order to put everything in this inequality so that only A is unknown, at least I should know what is X, Y. Then only I'll be able to find out A. So Y and X have to be a finite number. So that is where the bounded value, right?
Yeah.
Okay. I found out X less than or equal to A. So tell me, initially it started from x greater than or equal to a, and now I've found out x less than or equal to a. So that means x lies between a to 1 by a, right?
Yeah.
And what does it mean? So it
Ma'am, one
sounds,
second. One second, ma'am. Is equal to a and x is okay. X is greater than or equal to a and x is less than or equal to 1 by a. Then x is between. Yes, ma'am. Done. Sorted. Yes.
now when I have found out, that means a is smaller and 1 by a is bigger.
Yeah.
What does it mean? When you have a number which is smaller and its reciprocal is bigger, that means a is smaller, right?
A is smaller. Yes.
So, if this is the condition, this means a square is less than or equal to 1. That means a is less than or equal to 1.
Yes.
Anyways,
We
so
solved the condition for a now.
for a. So a
For a.
is
Yes.
actually, because if you take a greater than 1,
Ma'am,
this,
your voice is cracking, ma'am.
I don't know why it's happening. I mean, of course, it is network issue, but why now? इतने दिनों बाद क्लास हो रही है, मत करो ऐसा. um
Ma'am, अब से हर रोज can we keep 1.5 hour lectures only?
हाँ,
That's fine. 9 to
ठीक है,
10:30 works, ma'am.
ठीक है. 9 till 10:30. So a is less than or equal to 1, right?
Yes.
This is the condition, because if I keep a greater than 1, then this condition will not hold. What does it mean? Region is shrinking. A's
Hmm.
value is lesser, right?
Yes, less than 1.
हाँ. A
Less than
is
or
less than
equal.
1. So from here
Ma'am,
I can,
technically, yeah, less than
हाँ,
1. Huh.
please go ahead.
No, it should be less than or equal to 1.
हाँ. Less than. So a is less than or equal to 1. Now if we want to find out other values also, for this is it for the part. But for x and
Huh.
y also, the maximum value which is allowed, you know that y plus ax is less than or equal to 1.
Hmm.
So that means y is what?
Y is less than or equal to 1 minus ax.
Right. Also, y is greater than or equal to 0.
Yes, ma'am.
So this is the condition that y lies between,
Y lies between 1 minus ax and 0.
and if you want a feasible x, what is, for feasible x, 1 minus ax has to be greater than 0.
Yeah.
So these are the condition that y is actually 1 minus ax. Now I have found out some of the conditions. For y, this is 1. For x, this one. And for a. Is it fine?
Hmm. Yes, ma'am.
Of the feasible values for all of them. Now it's time.
Ma'am, your voice is breaking, ma'am.
Sorry about that. Um, let me read the question.
I'll revise this whole KTT tomorrow.
Yeah.
I'll have to watch this.
I was
It's
saying,
nice, but then
Purjit,
at the same time, it's bad. ma'am.
my drive is, though I had extended it to 200 GB, and still
हाँ
it is still full. So I was thinking that you'd share with me,
हाँ मैम, I'll do
I'll
it